Picture a scenario where you are chilling on your couch and your phone rings. The number is unknown to you. Out of curiosity, you pick up the call and there is an agent on the other side who claims that you have been awarded Indian rupee 10 lakh in a random lottery. He asks for your bank account details to credit that amount. Looking at such a huge amount, you get excited and start sending him your bank details. After some time, you check your account only to realize that your account has been wiped clean. It dawns on you that you have been defrauded. It could have been avoided had the call been marked as spam. This is where classification comes in. Nowadays, phones have an inbuilt spam classifier such as the app Truecaller. It classifies phone numbers as spam and not spam based on previous reviews on the numbers given by the users. Spam classifiers are also used to classify mails and messages. Hello and welcome to Maya. In this article, I will be discussing classification. Classification algorithms are used in wide range of businesses, from e-commerce transition to detecting fraudulent transactions. For example, Amazon studies your buying patterns to recommend you similar products that might interest you. Like you want to buy a laptop with the following features: 8 GB RAM, 256 GB SSD, i5 10th generation, 2 GB graphic card, 14-inch Full HD display, etc. at a price of Indian rupee 50,000. You are searching for these high-end features at the lowest possible price. Amazon notes this behavior of yours and their classifier puts you among the cluster of people who look to buy good product at a low price. So the next time you visit their app, they will show you the high quality products which are available at discount or lower prices. The application of classification algorithms are not just limited to businesses and spam classifiers, but are also used in natural language processing, medical science, etc. Why do we need machine learning algorithms to do the classification? Let's understand this problem with the following example. In today's world, there are billions of people active on social media. They share a variety of things on the internet like photos, videos, memes, messages, etc. But there are certain groups of people who post hate speeches or controversial photos or videos that might trigger social distress, which may result in violence. Now, these hate speeches need to be removed from social media as they are harmful. So what are the ways in which we can accomplish this task? One way is to hire people who will remove this harmful material from the platforms, but it will be inefficient as it will take a lot of time to complete the task. And by that time, it may have triggered violence somewhere. Also, the person which the company had hired might be biased toward a certain community and may not remove certain posts, which again might lead to violence. To overcome these problems, we have machine learning algorithms to accomplish the task of removing harmful material from social media efficiently and unbiasedly. So how does classification work exactly? Consider a box containing geometrical figures such as cubes, pyramids, spheres, cones, and cylinders. Now you are provided with 5 boxes that have the logo of a cube, pyramid, sphere, cone, and cylinder respectively. Your task is to separate the shapes and put them in the box with their respective logos. This process is called classification or categorization. In this video, we will be discussing the following topics: two-dimensional binary classification, 2D multiclass classification, multiclass classification, and clustering. We will be covering the first two items in the part first of this video. Two-dimensional binary classification. Suppose we have thousands of pictures of cats and dogs with one folder labeled as cats containing pictures of cats and another folder labeled as dogs containing pictures of dogs. We fed these pictures as input and labels as output to teach our classifier to differentiate between cats and dogs. The sample which we use to train our machine is called a training set, and a sample set which we use to predict the output is called a testing set. This is an example of supervised learning. In supervised learning, we guide our machine to distinguish between things. In this example, our input data belongs to only two different classes. Since there are only two possible classes for every input data, it is known as binary classification. The technique used for classifying data is called boundary method, where the input data is plotted and line or curve is drawn separating the two classes. Some boundaries are better at predicting the result than other boundaries. Let's take an example of the two variants of the iris flower, setosa and versicolor, for better clarity. We have two features of the flower, that is petal length and petal width. Based on these two features, we plot the graph and can draw a line separating two classes, that is setosa and versicolor. 0 represents setosa and 1 represents versicolor. We are done with our classifier here. Now, when we feed our machine with some unseen data, it will classify whether it is versicolor or setosa. Now, let's suppose that we have increased our data set and plotting it gives us this graph. In the above graph, we can still separate the classes, but this time the line is not straight, it is curved. This isn't a problem as we can still classify the flowers. The color blue represents setosa and orange represents versicolor. We call the sections onto which we chop up the plane decision regions or domains, and the lines or curves between them as decision boundaries. Now suppose we receive another batch of data of flowers from a different region. We again plot the input as before, and this time we get the image as shown in the figure. This time it is difficult to draw a boundary in spite of having a blue and orange region. In this case, instead of predicting a single class with absolute certainty, we assign probability to each possible class. The point in the orange region implies that the flower is versicolor with the highest possible probability, and the probability goes on decreasing as we move from the orange to the blue region. Similarly, the point lying in the blue region implies that the flower is setosa with the highest probability. If we don't mind getting the false positives or false negatives, we can use the idea of accuracy or precision to draw the curve that separates the two classes. When the decision boundaries are sharpened, the probabilities are simply 1 or 0. On the other hand, when the regions are fuzzy, each class will have some non-zero probability. Whether be the case in practice, we need to convert probabilities into decision. Now, 2D multiclass classification. As we learned more about iris, we got to know that there is a third variant named virginica. Now we have three classes of iris, that is setosa, versicolor and virginica. Again, we need to train our machine to distinguish between these three variants like we did in binary classification, but this time the machine needs to distinguish virginica as well. So next time when we feed new data into the machine, it will distinguish it as setosa or versicolor or virginica. This task of classifying more than two classes using 2D input is called 2D multiclass classification. We need to find boundaries defining multiclass region. Some common algorithms used for 2D binary and 2D multiclass classifications are logistic regression, k-nearest neighbors, decision trees, support vector machine, and naive Bayes. In this article, I talked about 2D binary classification and 2D multiclass classification. In next video, I will talk about multiclass classification and clustering. Thank you for watching the video. Hope this video was informative. Please like the video and subscribe to the channel.